This webinar. My name is Dani Gunawan. I'm a lecturer at the Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. I will be the moderator for today's event. I would like to extend my warm welcome to our honorable speaker, Associate Professor Dr. Rabia Abdul Qadir from Institute of IR 4.0, University Kebangsaan Malaysia. And also welcome to Vice Dean 3 of Faculty of Computer Science and Information Technology, Dr. Maya Sylvie Lydia. And also welcome to all the participants. Today is a special day. We will have a lecture from our visiting professor, Associate Professor Dr. Rabia Abdul Qadir, who will present the lecture entitled Semantic Text Analysis for Ambiguous Queries in Web Search. This event is the part of the world-class visiting professor program held by the Universitas Sumatera Utara. Okay, before we begin the lecture, first I would like to invite Dr. Maya Sylvie Lydia, the Vice Dean 3 of FASCOM TI, to deliver the opening remark. So for Dr. Maya, please, the time is yours.
Okay, thank you, Dr. Dani, Pak Dani. On behalf of the Dean of the Faculty of Computer Science and Information Technology, USU, FASCOM TI, I would like to express my sincere to Associate Professor Dr. Rabia. Alhamdulillah, today Allah is still giving us health and opportunity to take part in this seminar. First of all, thank you to Associate Professor Dr. Rabia Abdul Qadir who accept our invitation to give a guest lecture today. I used to call Dr. Rabia as Kak B. Okay, now today thank you for coming to our campus virtually. Okay, also thank you to the audience who participate in this seminar. We hope this collaboration will not end here, but we can be continued in the next year. Inshallah, this activity will be broaden our insight and strengthen USU's collaboration with UKM. Institute of IR 4.0 is still in UKM. Is under faculty or under UKM, Dr. Rabia?
Under faculty,
under faculty.
No, it's under UKM. So it's independent.
Under UKM.
Yeah, it's independent institute.
Okay. Now maybe we have a collaboration with the UKM, and the next we have to make a collaboration with the Institute of IR 4.0, inshallah. Okay. Now we can go to the guest lecturer, and for the participants you can ask the questions maybe in Bahasa Indonesia. Maybe Dr. Rabia will understand the Indonesian language, right? Or maybe Pak Dani will translate to English. Okay, for me, Assalamualaikum warahmatullahi wabarakatuh, and thank you for all.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Mai, for the remarkable speech. And for those who just joining us, welcome to this webinar. And just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the chat box. Or later, you can, after the presentation, you can turn on your microphone and talk to the speaker. Which way it will be convenient. It will okay. If you ask in the chat box, I will bring them up during the presentation, and we will also have the time for our questions at the end. So now, without further ado, I'd like to introduce our today's visiting professor, Associate Professor Dr. Rabia Abdul Qadir. She's a senior research fellow at the Institute of IR 4.0, University Kebangsaan Malaysia. She received her PhD in 2008 in computer science from University Kebangsaan Malaysia. Currently, she is a head of quality assurance, Institute of IR 4.0, and also head of intelligence data analytics lab, Institute of IR 4.0. Her areas of research are in computational linguistics, intelligence computing, big data analytics, and also information system. Now I'd like to invite Associate Professor Dr. Rabia Abdul Qadir to give keynote speech about semantic text analysis for ambiguous queries in web search. For Dr. Rabia, the time is yours, please.
Thank you, Pak Dani. And Assalamualaikum and very good morning to Dr. Maya, Izzy, Lydia. You call her Dr. Maya. I mean Maya only. For the welcoming speech, and also Pak Dani Gunawan as a moderator for the session, and to all the participants that I believe that masters and PhD students from this faculty, what Fasilcom CI. Is it the short form or the full? What is the full name? The short form. The full name is Fakultas
Ilmu Komputer dan Teknologi Informasi.
I see. Okay. All right. So I just put it as a Fasilcom because I don't know what is the full name of the faculty. Yeah, but I know USU is a is a Universitas Sumatera
Utara.
Yes. Okay, so for today, let me share my screen. Okay, so today I would like to share just part of my research, okay, which is related with the natural language processing. Even though as mentioned by Pak Dani just now, I'm also doing analytics, big data analytics, okay, but my expertise is on natural language processing, which is specifically on computational linguistics, okay, dealing with the sense of text and also the semantic representation of text. All right. So after a few years of finishing my PhD in 2008, when they come with the big data analytics, so since in NLP we also working with AI algorithms such as machine learning and others. So I moved to instead of text analysis or natural language processing, I moved to another research area which on the big data. Okay, so my discipline of research for now is just concentrating on the natural language processing and big data analysis. So today I just want to talk about the on the natural language processing, but it's a part of my research work for NLP, which is semantic text analysis for ambiguous query in web search. Previously, I'm actively doing knowledge representation. Okay, so semantic knowledge representation for I think 5 to 6 years with that area. Then slowly moved to ambiguous query. It's because I would like to increase instead of working with the knowledge processing, the knowledge representation, I'm also looking for the front end processing of the query. So The query can be a text-based, the keyword-based, or long query or short query. So when I go to this query, what I can see that the big problem in the natural language query processing is on ambiguous query. Until now, actually, the result of the processing of the ambiguous query is not really good enough, but we keep on continuing with the problem of the ambiguous query from time to time. Okay. So today, my presentation will based on the following outline. I started with the overview to refresh. Okay, I started with the overview just to refresh and warm up with the scope of querying in web search. And then I followed with what is ambiguous and how to tackle ambiguous query in a web search. And then we're sharing the approaches in solving the ambiguous query in web search by implementing word sense disambiguation. So just for today, I just take two approaches of WSD or word sense disambiguation, which is machine learning based and also knowledge or dictionary based. Then we will look at the goal, okay, of word sense disambiguation and how this goal approaching the advantages of implementing word sense disambiguation in natural language application. So after all, I end up this presentation with the application that implementing WSD. All right. So just to give you some idea and also give you some knowledge or to warm up the idea for today's speech. Okay. So everybody are using query. Okay. Everybody are using web search. Is it clear, my voice?
Yes, clear.
Okay. All right. So now these people are familiar with the web search. Okay. So, but in the web search, before we can get whatever that we want, okay, we have to put some query there. Okay. So therefore, the querying in the web search area nowadays has become attracted computational linguistic community in the last few decades. Okay, due to the people who are actively using the web search to find something. Okay, and the most popular web search is Google. Okay, even though we also have other search engines such as stated on the slide, Yahoo, Ars.com, MSN, Bing, and also About. There are many others actually, people who are using web search. So, which is nowadays people are not using the web search for their work only or for the education purposes, but people are looking more than that, such as looking for recipes, searching for images, facts, photos, and whatever material that they're looking for in their daily life. So the process involved is a QA process. okay, which you are not expecting the right answer. Okay, people basically when they do asking, when they do a web search, they don't care they don't care what is the exact answer, but at least they get some feedback. Okay, at least they get some feedback from the web search for them to get some idea and start with. Okay, for example, when they are looking for the recipe, okay, so searching by keywords will be fastest and easiest. Okay, but sometimes what the result that given by the web search is not really accurate. Okay, so that's why the scientists of computer science, those who are specifically working with the research in NLP, keep on improving in giving the right answers or the relevant answers to the users by doing research on question answering processes. So this is about the question answering processing. When we are dealing with question answering processing, basically we are dealing with the three types of process. Okay, the first process will be the query, meaning that how do you want to process whatever query given by the user. And after all, you will concentrate on document processing because you want to link in giving the answers. And finally, provide the answers. Okay, in providing the answers, we basically the system will look at the most relevant answers either by keywords, okay, either by keywords or by phrases. So for this talk, for today's talk, I just focus on the query processing. I would not touch on the document processing and also answer processing. Okay, because in the query processing, it's actually the main process when we are dealing with the question answering. Okay. Okay, so for the ambiguous, I just have to put down the all right. For the inquiry processing, we must consider the context in which each word a question are posed. Okay, when we are looking for the context in which the question are posted by the users, there might be an ambiguous word appeared. Okay, so what we need to do here, okay, in our query processing, we have to decide which of their several meanings is intended in a given text is known as word sensitive ambiguation. Okay, so when we are dealing with the ambiguous word, what we need to do, we have to see the context, okay, the relation between the words and other words if the query given by the user in a form of phrases, more than one word. If the query is come up with a one word query, that will be no problem. Okay, but if a query involves more than one word and it could be a question, it could be a short phrases or long phrases. There might be an ambiguous word inside or within the query. So this is the challenge, okay? This is the challenge when we're trying to work with the ambiguous word, which is the solution we always call as a word sense disambiguation. All right. So what is ambiguous actually? So open to having several possible meanings or interpretation, or sometimes equivocal. Okay, sounds like the same, but spelling might not the same. That is involved when we are dealing with the speech conversation. Okay, but when we are dealing with the text, we are just facing definitely the ambiguous word basically having the same spelling, but it's given a different meaning. For example, okay, this is in linguistics. For example, a book. Okay, so a book here, it can be a book, all right, that we read, or it can be a reservation. So in this case, if you ask your web search, okay, if you put the input on
Professor, your voice is mute.
Kok dia mute, Mak? Aduh.
okay,
Okay.
where am I just now? Still on ambiguous,
a
right?
sentence before. Yes, still the ambiguous.
Same slide.
Yeah, same slide.
Okay. So in this case, the book. Okay. Book have a different meaning. One is for a book, and one is for the act of making a reservation. Okay. If you put in your web search, okay, if you put in web search in the text, in the field of inputting your query, you are saying that I would like to book a luxury hotel. So with this query, the system, they might not look book here as a book, but the book here as a reservation, acting to do a reservation. Okay, but the spelling is the same. Okay, so how we solve it? We will look at the context. Okay, we will look at the context of the phrases. Okay, we have no problem with one keyword query, but we do have a problem when we dealing with more than one word query in your web search. Alright, so it's a doubtful or uncertain, and it's difficult to comprehend, distinguish, classify. Basically, yes, we do. When we are dealing with the processing of the natural language, we do having a problem in giving or dealing with the ambiguous words. Of course, the outcome of the search will give you a different answer on or inaccurate answers because of the lacking the clearness and definiteness, actual and also indistinct for the ambiguous word. Okay, there is a 5 types of ambiguous words. Okay, this is by Annes, Leora and Charles by 2016. what they said about previously was two types of ambiguous in 2011, but after Anders, Liora, and Chow in 2016, they figured out 5 ambiguity that we can separate, okay, in terms of the processing. Okay, so the first one is a lexical ambiguity. Lexical ambiguity is referring to the structure of the word meaning, okay, the meaning of the word. All right, and then semantic ambiguity. We are trying to look at the relationship between the ambiguous word with the prefix and the suffix of word. I mean the word before that ambiguous word and the word after the ambiguous word. From there, we can see the semantic relationship for the word of ambiguous. And pragmatic ambiguity, instead of looking for the word relationship, for pragmatic ambiguity is looking for the sentence relationship. If the semantic relationship doesn't give any good result for the ambiguous processing, we might go for the higher level, which is called pragmatic ambiguity, meaning that we are looking for the relationship between the sentence that contain of ambiguous word and the previous sentence and the right after sentence of the ambiguous word. And the next one will be the structural ambiguity. This is the simplest ambiguous processing, because we're just looking for the syntactic, okay, the sequence of words in a sentence. And finally is anaphoric ambiguity. Okay, anaphoric ambiguity is looking for the word pronouns such as she, he, it. Okay, because those things are referring to somebody or referring to things. Okay, but who are they are referring to? So that is another word that we also call as ambiguous. All right. So how to tackle? Okay, we gone through the what is the meaning of the ambiguous, meaning that we have an uncertain result of what is the meaning of that word, because the ambiguous word basically it gives more than two meanings. All right. So when we do a natural language processing, will tackle this ambiguous word in ambiguous query. So whenever the users add input their query in the web search, okay, what we will do, we will analyze the text. Okay, we will analyze the text semantically, okay, to see the context relationship between prefix and suffix of the ambiguous word. Okay, that is the first step. Okay, we look at the semantic. If we couldn't get it, and then we will go for the pragmatic. But in research, sometimes we just concentrate on the semantic text analysis. Okay, because if we go more to the pragmatic, that thing will be confusing. It is good in doing a research. We just concentrate in a small part. Okay, if we choose one type of the ambiguous, just concentrate on that one type, because that type also involves a lot of processing. Okay, a lot of processing that we should consider until we get the answer, and either our contribution is good or not. Okay, after we do the semantic text analysis, and then we will go to the word sense disambiguation. Okay, once we are working with the text and once we are working with the semantic text analysis, definitely you will get the semantic word relation. Okay, meaning as I said previously, it gives a context of that context of relationship of that ambiguous word for the prefix and the suffix of words. And then we will rely on the knowledge base. Okay, knowledge base, either we basically knowledge based approaches is a not supervised, and the other one is a corpus based supervised. It's a corpus based, which is it's a supervised. Okay. What is the difference between corpus and knowledge? Knowledge can be anything from outside, but the corpus base is you are working within a scope. Okay, if you are working with the medical field, so meaning that your corpus is a medical field. So you are doing natural language processing, or you are doing a text analysis within the medical field. Okay, so when we are dealing with the knowledge base, it can be anything. Okay, there is no specific field that we are working with. Basically, the researchers in natural language processing, they are working in corpus base, okay, because otherwise the thing would be very robust, and to finish your masters or PhD will take a long time. But knowledge base can use to support, okay, but basically the corpus base is more relevant for masters and PhD within a some period of time to finish it. All right. So word sense disambiguation approaches. This is the when we know that this is what that we want to do. Okay, we are trying to disambiguate the word by giving the sense. Okay, so for the word sense disambiguation, that is the common term, okay, to do disambiguation based on the word sense. Okay, it's a word sense disambiguation. If you Google this, there will be many references, okay, on the WSC research work. Okay, so this is an important but challenging technique. It is, okay, in the area of natural language processing. So there are hundreds of WSC algorithms and systems are available out there. Okay, but less work has been done. Okay, because we have a problem to choose the optimal WSC algorithm. Okay, so we do implement a few, okay, algorithms. So today I just want to share just two, okay, just two approaches. Okay, there are more than that actually. So today I just want to share about the machine learning, but I will share in terms of the various type of learning, okay, which is looking for the supervised, unsupervised, and also semi-supervised. And the second approach will be knowledge or dictionary based. Okay, so this is involve the external lexical resources. Okay, so for the knowledge base, we always involve with external lexical resources like WordNet, dictionary, thesaurus, and others, ontology. Okay, so those are supported the knowledge base approaches. All right. So this is when we are still seriously working on the word sentence ambiguation. So the idea, so the concept, or the conceptual model of WST here, okay, is to work with lexical knowledge. Okay, work with the lexical knowledge, where we know that the idea of WSD is to find the correct sense of the word and automatically assigning its correct sense to the word which are polysemous in a particular context. Okay, words that giving more than one meaning. Okay, if we consider a lexical knowledge here, it's a sequence of words. Okay, lexical knowledge and also word knowledge, it could be a collection of words. Okay, then the WNC task is assigned to the correct sense for all some words in the text. Okay. As I mentioned before, there are two approaches, okay, which are used in WSD, machine learning, and also knowledge-based approaches. So machine learning based approaches, the system are trained. Basically, the words, the ambiguous word that we identified will be trained to perform the task. Okay. Then a classifier is used to learn features and assign unseen examples. So in this machine learning approach, the initial input is the word to be disambiguated called target word, and the text is embedded. Okay. So whereas knowledge and dictionary-based approaches, all the sense of the word needed to be disambiguated are retrieved from the dictionary. The dictionary, it could be, we put it in a word knowledge. Okay. So from there, we can get the sense of knowledge. Okay, by referring to the word knowledge in your processing, you will see the sense knowledge, and also supported by the contextual features here. So the contextual features, together with the sense knowledge that comes from the knowledge base, and then we come up with the word sense disambiguation matching, okay, through the matching process. So this is basically the idea of the conceptual model, but the content of it can be changed according to whatever approaches that we are working with. I just want to, as I mentioned earlier, so I just focus on two approaches of the WSD, okay, to dealing with the ambiguous words. So here, a classifier is used to learn, feature, and assign sense to unseen. Okay, in these approaches, the initial input is the word to be disambiguated or target word, and the text in which it is embedded called as context. So features are themselves served by the word. The features of word is actually come from the word itself. Okay, the value of feature is the number of times the word of word occur in the region surrounding the target word. So the region of often fixed window with target word as center. So there are three types of technique in machine learning, which is based on supervised technique, unsupervised technique, and semi-supervised technique. So I will go one by one, or for every single technique that we are for today. Okay, supervised, unsupervised, and also semi-supervised. We look at the supervised. Okay, it used machine learning techniques for including a classifier for manual sense annotated data set. Usually, the classifier, often called word expert, is concerned with a single word and perform a classification task in order to assign the appropriate sense to each instance of the word. So the training set, when we are dealing with the machine learning, there would be a training set before we really implement the end of the machine learning process. Okay. So for the supervised learning, the training set basically used to learn the classifier typically contain a set of examples in which a given target word is manually tagged with a sense that the sense inventory of the reference dictionary. Okay. So I haven't said that machine learning is not using the knowledge base at all, okay? But the dictionaries or the knowledge base also still can support, okay, in giving the sense of the word, of the target word. Okay, in our case, our target word is ambiguous. So for example, when you have a child, okay, which is, I just want to give you the scenario, okay. What is the meaning of the training set? And then looking for the target word is manually tagged, okay. So your child, for example, we have a child, so this child is our target, okay. This child is an ambiguous word. Okay, the child doesn't know how to read and write. Okay, so she or he is being taught by the parent when they are at home and taught by the teacher when they are in school. All right. So because of what? Because we try to give something to the child. Okay, that is the idea of training. Okay, we have a target object and then we give them something to train or to input some knowledge. Okay, so the children are trained to recognize alphabet and then to recognize some numerical numbers, just to train that the child or the target we know how to read and how to write. Okay, so this event basically we call as a supervised. Okay, because every single activity to that child, to the target, to give a knowledge of reading and written is monitored by the teacher at school and by the parents. So the teacher and the parents here is someone who will supervise the target. Okay, so then after that, the child will able to read and write, or so that is considered the outcome. Alright, so that is how the supervised machine learning works for the ambiguous word, to identify the ambiguous word and giving some meaning of that ambiguous word. Okay, so we have to train the ambiguous word by supervising, by providing the knowledge to that target word. Okay. So basically, WSD algorithm give better result with other approaches. Okay, this supervised gives a better result Okay, so the method in supervised WFT, we have several methods. We will go one by one. Firstly, I would like to see to discuss about the decision list. So this decision list is an ordered set of rules for categorizing text instance. In the case of WSD, by assigning the appropriate sense to the target word. The target word is the ambiguous word. It can be seen as a list of weights by implementing if-then rules for the target word. A training set is used. How they train, as I mentioned earlier, for inducing the set of features. The idea of the training is to giving the set of features to the word. When any word is considered, first its occurrence is calculated and its representation in terms of feature vector is used to create the decision list. Okay, so how to come up with the decision list is basically looking for how the frequency of the target word appeared and also the representation of the target word in terms or in your query. So after all, we calculate the score, and if the score giving the more, the score is giving the highest, okay, so it will give more sense. Sense here is referred to the meaning that we are looking for the similarity. Okay, so we are calculating the similarity of the word with another meaning. Okay. So second is a decision tree. This is another method, also in a supervised technique. Okay, in machine learning, but there are another method to identify the ambiguous word or the target word. So basically here in this method or approach, divide the training data in a recursive manner and represent the rules for classification in a tree structure. Okay, it's not if-then rules as what we have in decision list, but here we represent the target word in a tree form, okay, or in a tree structure. The internal nodes represent tests on the feature, and each branch shows the decision is being made, and the leaf nodes refer to the outcome of or prediction. Okay, the branch is actually looking for the decision. So we are using for decision tree. Basically, we are using a binary tree. Okay, because the chances it could be yes or no. Okay, for example, in this case, the sentence is I will be at the bank of Narmada River in the afternoon. All right. So the bank here, they will target a tree that have a bank account. Okay, is it a bank account? But not sure. Either the bank here is a bank account. Okay, so there will be no and yes. There will be 0 and 1 answer for the decision tree. Either the bank is referring, it could be, okay, because the leaf node is referred to the prediction, but not yet the answers. Okay, until we are very sure. In this case, bank account is bank of, because bank of that could be a bank account again or another bank of country. All right. So for the first branch, just a prediction, it could be bank. The word bank here is referring to the bank of finance. All right. So, but it, because there is another branches, okay, the searching will continue until there is no more branches. All right. So first answer, it could be finance, but it will go traverse to another choices. Either the bank is referred to account or is referred to country. All right. So basically, they will look at the prefix and the suffix of the word bank. Okay, so if we go for the bank of country, there is yes here. So by looking of the bank of country, it will have any choice, a choice. Either the bank is referred to the river or the bank is referred to the finance. Okay, so which one the yes and no answer here? Okay, if the sequence of the query here showing the yes is referring to the bank finance, then the result of this ambiguous bank is a bank that refer to finance. So the third technique, or still unsupervised, is the naive bias. Okay, naive bias is a simple probabilistic classifier based on application of Bayes' theorem. So it is formulated by this formula. It refers to the calculation of the conditionally probability of each sense S, okay, sense of Si here, of a word W given the feature Fj in the context. Okay, so the sense S which maximize the following formula is chosen as the most appropriate sense in context. Okay, by considering the sense I of the word W given by the features that we already have. Okay, so we do a calculation on it, and that if the result of S here have a maximum result, that means that is the most appropriate sense in context of that target word or ambiguous word. And fourth, for supervised technique, is a neural network. The neural network process information based on computational model of connectionist approach. The input includes the input features and the target output. Okay, features is very important. Features is represent the sense. Okay, so the features, the input features is important to identify or to recognize either the target word is ambiguous or not. Okay, in neural network, the training data set is divided into sets which are non-overlapping based on desired response. So the network encounter new input pair, features could be more than one, that the weight are adjusted so that the output unit giving the target output has the larger activation. So basically, by giving the input and adjusting of the weightage in every layer, okay, in a neural network, it will give you an output. So the output here is giving you the prediction of the meaning for that particular target word. we have four methods, techniques, okay, in supervised technique or machine learning approach. So another technique in machine learning, which we call it as an unsupervised technique. So this is unlike supervised approach that we discussed just now, which is it does not need the hand level knowledge of sense information in large resources for disambiguation. Okay, supervised learning needs a large corpus because we want to figure out the features, okay, to give a sense to the ambiguous words. But in unsupervised, we might not need this knowledge, okay, what we call as a level knowledge. So it is based on the fact that words having similar sense will have similar surrounding words. Word sense are derived by forming cluster of occurrences of words, and the task is to classify the new occurrence to the derived word. Okay, in unsupervised technique, we just count how frequent the word appear. Okay, this approach, instead of assigning sense level, it detects the cluster. Okay, in unsupervised machine, instead of predict the sense of the target word or ambiguous word, it also will, in unsupervised, will giving you the next process, what we call it as a cluster. Okay, same as a supervised technique, there are a few methods, okay, involved in the unsupervised technique. The first is a context clustering. I think I have to get some drink. Sorry, I have to drink. All right. Continue with the context clustering method for unsupervised technique. So this context clustering is based on clustering technique, okay, in which first context cluster are created and then there will be grouped into cluster to identify the word. Okay, based on this clustering technique, what we need to do, we have to create the context vector and then we group it, okay, to identify the meaning of word. So basically, this method will use a vector space as a word space. Okay, the vector space is referred to the word in corpus, and its dimension, the dimension are words. Okay, so how many times the target word occur. Okay, from that, we will produce the co-occurrence matrix to give the similarity measure. Okay, we will produce the co-occurrence matrix, and then the similarity measure will be applied based on or by looking at the co-occurrence matrix. So then discrimination is performed using clustering technique. This is the idea of the clustering technique in unsupervised. And then word clustering. This technique having similar meaning as assigned to the same cluster. Okay, so the technique, those who are having a similar meaning are assigned to the same cluster. To figure out the similar meaning okay, of the particular of word, that would be by implementing the word clustering, okay, to see, of course, there will be a calculation to see the weightage. Okay, then after the closest value will be clustered, and then it will give the meaning of that word. So in this case, if we have a word, for example, a W is a word that an ambiguous word that we have, okay, which is similar to a few other words, okay, then the tree is formed initially with only one node, and the node of the word W, okay, will have a child WM or WI. If we look if you still remember, just now we are talking about the binary tree in supervised technique. Okay, but in this unsupervised technique, the tree, it could be it's not just a binary tree, it could be more, because the child of the target word that we have, it be presented WI until WN. Okay, there are many words in the same level of tree. So the another approach mentioned is called clustering here. Okay, each level, okay, by will be clustered by committee algorithm that present each word as a feature section. When target words are accounted, a metric called similarity metric, same as the previous technique, they're looking also for the similarity metric. So the previous one, they call it as a co-occurrence. And in this, but the idea is the same. Okay, it's constructed who each element is similarity between two words, between W, one word to another word, based on the tree that form in the process of text analysis. Okay, in the subsequent step of this algorithm, committee are formed from a set of words W is recursive manner. Okay, when we are dealing with a tree structure, okay, we are dealing with the recursive. So the clustering algorithm then try to find those words not similar to words of any committee. Okay, it contradicts with the another step previously. Okay, the previously in binary tree, we are looking those who are close. Okay, those are giving yes answers. But in this word clustering, okay, for unsupervised technique, we try to search the word is not having a similarity, because we want to take out. Okay, we want to put we will not cluster the words that are not similar. That is why in word clustering method, we just focus the searching, looking for the non-similarity words. Okay, if there is not similarity, that means the word will be put away. Okay, and it just clustered all the words in similarity. So those words which are not part of any committee are again used to form another committee. Maybe the word that we put away because it's not similar with our target word, and then that word will be taken away, and also if there is another committee that will use that word. So in the final step, each target word belonging to W will be a member of committee depending of its similarity to the constraint of the committee. So we take out the non-similarity and then we just consider the most similarity word. And then the third tag method for unsupervised, the third method for unsupervised is co-occurrent graph. Okay, so these are dealing with performing a graph or creating a graph. Also looking for the co-occurrence. Okay, so because to look at the similarity, to figure out either the word is similar to the target word. Okay, so in computer science, okay, we just look at the co-occurrence and we can present it in a different form. Okay, so previously there will be a binary tree, there will be a tree, and then for this third method, we present the occurrence value, the occurrence word become a become a graph. Okay, which is when we are dealing with graph, meaning that we are dealing with the vertex and also the edges. So the vertex represent the word in text. Whatever word that happen to be as a input, that will be the vertex. And E or edges is edges if the word co-occur in the relation according to the syntax in the same graph of text. If there is no co-occurred word, okay, so just put it away. Okay, that is the idea. And then for each edges, we will be given a weight. Okay, will be given a weight based on the formula. So how to giving a weight is based on this formula. Okay, the P, okay, the PWMWN is referred to the frequency. Okay, if you notice, every single processing or analyzing a text here, we always looking for how frequent the target word appear. Okay, and that is always the key for us to do some analysis of text. Okay, for this ambiguation. Okay, so the weightage is based on how frequent the word M and the word N here appear. Okay, where the frequent MN is the co-occurrence frequency of words of WM and WN. Frequent N is occurrence frequency of WN. WN is another word. WM is another word. M and NN. So word is high frequency is assigned by weight 0, and the word which are really co-occurring assigned by weight 1. Okay, that is the idea. It's a standard value to represent the weightage. So edges who weight exceed certain threshold are omitted. Then an iterative algorithm is applied to graph, and the node having highest degree, relative degree is selected as hub. Algorithm comes to the end when frequency of word of to each hub reach the below threshold. Okay, it keeps on repeating the text until we get the below threshold. So at last, the whole hub is denoted as sense of the given target word. So the hub of the target word which has 0 weights are linked, and the minimum spanning tree is created. Okay, from the graph. So this spanning tree is used to disambiguate the actual sense of the target word. So from the co-occurrent graph, that after they're running this, implement this formula, okay, after they lower the threshold, it will stop and produce a spanning tree. So the spanning tree, whatever have in the spanning tree will consider the disambiguate of the actual target word. The semi-supervised technique, this technique is actually not that frequently used. Basically, the information is present like in supervised, okay, but might be less information is given. Okay, if we notice that in supervised, we always working with the features. Okay, in semi-supervised, very closely with the supervised, but the features given is lesser. Okay, the semi-supervised technique is not that popular as supervised or unsupervised method. Okay, because I think because the information or the features given during the processing of WSC is lesser, so the result could be less accurate or less relevant. So the idea of the semi-supervised is actually same as supervised, just cut off the information. All right, the next approach. Okay, this is the second approach that I would like to cover in this talk. Is a knowledge dictionary-based approach. This is the most popular approach in WSC. I can say that it could be easier because we are not dealing with the directly dealing with the formulas as what we have in machine learning approach. Okay, so we have neural network, that will be a calculation, that will be a formula that we have to consider, that will be the features that we have to identify earlier, okay, for supervised. But in dictionary-based approach, what we need to do is we just do some matching. Okay, so the disambiguation process is referring to the support knowledge. Okay, it could be a dictionary, it could be knowledge already presented in ontology or WordNet or any other treasure that supported the processing. Okay, it's very simple process, but dealing with more lexical. Okay, because we are dealing with several outside knowledge. Okay, rather than we work with the specifically corpus based as what we discussed in machine learning approach. And then the same as machine learning, we have a few approach or few techniques in knowledge or dictionary-based approaches. The first one is overlap-based approach. Okay, so this approach also call for the requirement of machine-readable dictionary. Reading the dictionary, that means looking for the dictionary as a supported document, supported resources to do the disambiguation process. So it includes a determination of the different features of the sense of words which are ambiguous along with features of the word in context. So basically, we are working with the less algorithm. So how less algorithm works here? They use the overlap-based approach, okay, that can be stated as if W is a word creating disambiguation. So, for example, the overlap-based approach. This is just an example. The pine and the corn. Pine is kind of evergreen tree. Okay, that is the sentence of pine. That is the description of pine. Kind of evergreen tree with needle-shaped leaves, with a way through sorrow or illness. So corn is to be solid body, which narrow to point something of this shape, whether solid or hollow, fruit of certain evergreen trees. So that is the description for pine and corn. So which one that saying that pine and corn is referring to the same thing? So what we need to do, we just do some searching of the exact word, okay, that exact similar between this the description of pine and corn. So the pine from sentence 1, that the word evergreen appear here. Okay, in there try to do a matching for others. Okay, in corn there is no others except for the sentence in 3. Alright, so it's not just doing the matching, but it will do calculate the how frequent that the word appears. Okay, so if the target would appear in twice, so the calculation will showing the number 2. Okay, so if the target would appear 3 times in this example, so the frequent will calculate that word is 3. Refer to the how frequent the word appear in our input. And then the Walker approach. So for the Walker approach, this algorithm can be stated as each word is assigned to one or more categories of subject and thesaurus. Okay, it refers to the thesaurus that we have. The idea of knowledge and dictionary, it just tries to match whatever target word to the thesaurus that we have. The thesaurus, it could be presented in many forms. Okay, so different subjects are assigned to different sense of words. For the case of Walker approach. And then selection preferences. Okay, find information of the likely relation of word type and denote common sense using the knowledge source. signs are selected will have harmony with common sense rules. Also counting how many times this kind of word pair occur in the corpus with syntactic relation. If you still remember what the syntactic means, it refers to the sequence of words of the input that we are put in as a query. Okay, so if that the highest counting will give you and identify the word that referring to the target that you are dealing with. Okay, so for this sense disambiguation approaches, supervise just a summarize of the two approaches that we discussed just now. Okay, supervised approach is perform better as what I said earlier, but one of its advantage is the requirement of the large corpora. Okay, so we need a large corpora because we have to identify the features before we can do the supervised training to whatever input that we put in. Okay, so without the large corpora, so the training is impossible. Training can be done with a small corpora, but the result will be not good. And for unsupervised approach, it does not rely on any such large scale resources for the word sense disambiguation. If we do have a large approach, supervised will be more meaningful or more accurate. But if we go for the unsupervised, okay, with their own methods or their own techniques for unsupervised, in terms of dealing, if we have a small scale resources, then go for the unsupervised. So that is a choice. Okay, that is a choice when we are doing disambiguation processing. If we have enough corpora or corpus, okay, and then look at the supervised. Okay, because supervised will give better output. Okay, in giving the weightage, in giving the prediction value for the ambiguous word compared to unsupervised. But if you don't have a lot, so go for the unsupervised. And then for the knowledge-based approach, make use of knowledge resources to decide upon the senses of words in particular context provided machine learning. Machine readable knowledge base is available to apply. Okay, if you have a machine readable engine, so go for it for the knowledge based approach. Okay, it's easier compared to the machine learning. I mean, in terms of the method. Okay, the processing is easier. And then the result is actually depends. Okay, it could be less accurate, okay, compared to the supervised. But sometimes if your problem is enough for the knowledge base, it could be give more. It would give you higher accuracy. So in terms of choosing what is the best approaches, it actually depends on your problem, depends on your corpus, okay, how big corpus that you have. So that is how you choosing the best method to do the word sense disambiguation processing. All right. So this is the advantage word sense. The advantage is when you apply the WSC, okay, in any application, then you can see, okay, because the idea And the goal of the word sentence abbreviation is to find the correct sense in which a word occurs in a sentence or a query when it can have multiple meanings. That is the goal. Okay. Find the correct sense. Okay. By if you are using supervised, look at the basics. Alright. So basically, the implementation of WSC in web search or other NLP application, it will improve the result of precision and recall for any natural language processing application. Okay, so how to say that the approach of the WSC is good or not for that particular problem? So we will see the common evaluation measurement, which is TF-IDF, looking for the precision and recall. And the application, okay, as I said that to see either your WSC is perfect, okay, not really perfect because we couldn't get the best result yet for the WSC solution here. Okay, even though there are many methods have been tested, but the result is still in low level, I mean very minimum. Alright. So the application that basically using WSC, we applied WSC in information retrieval. Information retrieval is actually the activity of obtaining information system resources that are relevant to an information need from a collection of those resources. So this is where the searching have been done. Okay, so it can be a keyword, it can be a full text. Okay, so or other context-based indexing information retrieval is the science of searching for information in the document searching, document themselves, and also searching for the metadata that describe data of database of text, images, of sound. So from the whatever text that you put in, okay, in a query for the web search, you can get nowadays you can get whatever output, okay, because they tried that already do some matching between your input and whatever outcome that you want. If you want a sound, that means that there is behind of it there is a matching, text matching to match your input, your query, and the database that they have. And then information extraction, WSC also applied in information extraction, which is this is a task of automatically extract structured information from unstructured or semi-structured machine readable documents and other electronically represented sources. So information extraction refer to the extracting information that unstructured or semi-structured. So basically it goes to the text retrieval. Sorry, text extraction. So WSC also applied in machine translation. Okay, so machine translation, that means dealing with one language to another language, translate one language to another language, for example, English to Indonesian, Indonesian to English. So WSC also been applied to see to giving more relevance of translation. Okay, when we are dealing with ambiguous words. So also dealing with the applied in question answering. Okay, so this is another computer science discipline. Okay, where the question answering is basically applied in information retrieval and also information extraction. Okay, to get the relevant answers. And then content analysis. So this is a research tool used to determine the presence of certain words, themes, or concepts within some given qualitative data. So using content analysis, researcher can quantify and analyze the present meaning and relationship of certain words, themes, or concepts. So WSC also been applied in this application. The word and text processing, if you notice, for the text processor now, it's not just you can input your text there, but it also gives you some analysis of the grammatical. Okay, if you write in a not right grammatical form, so the word processor basically will give you an idea of, to the right grammar. Okay, so in this case, WSC also been applied because when we put in any data, any input or any text, so we just put it, but sometimes in a different, in a wrong grammar, that the word processor able to recognize it and give the correct or suggestion. And also applied in lexicography. Okay, so in lexicography, we basically or separate into two groups. Either we go for the practical lexicographer, it's the art of compiling, writing, and editing. Whereas another lexicography is a theoretical lexicography. It's scholarly discipline of analyzing and describing the semantic, syntactic, paradigmatic relationship. And the last but not least, applied in semantic web. Okay, an extension of World Wide Web through standards set by the World Wide Web Consortium. Okay, so the goal of the semantic web here is to make internet data machine readable. So WSC is a process that we embed to any application to see the effectiveness. Okay, to see the effectiveness, either our machine able to recognize or to dealing with the ambiguous word. As a summary, there are many approaches, but we still haven't produced the best solution. Okay, because the result of the processing for the WSC still in a minimum accuracy. So currently, I'm still working with the WSC, the word depth standard integration. Instead of trying the tree, the knowledge based approach, so we changed the resources. Okay, and then we are using ontology now. Okay, so because the ontology is already giving the semantic relation, so we hope that the result of this WSC applying ontology as a knowledge base will be produce a better result. So that is my hope for my research on WSC, producing, improving the result to be useful and give more benefit in several applications that I just mentioned just now. Okay, so I think that's all for today. So I open for any question and answering.
Okay, thank you very much, Associate Professor Dr. Rabi Abdul Qadir, for the interesting speech about the semantic analysis, especially in the word tense disambiguation. According to your explanation, this topic is hasn't solved yet, right?
Yeah.
I invite the participants to ask the questions. You may ask directly by unmuting your microphone, or if you are confident with writing your question, you may drop your question in chat box. But before we read the questions from the participants, I'd like to ask you one question. So what is the current specific challenging topics? You said we have a lot of algorithms in with WSD. Is that still have an opportunity to a new algorithm, or maybe solve the WSD in specific language such as Indonesian, or maybe we should focus on the accuracy, or else?
Yeah, basically when we are dealing with the text analysis, our end result, we will look at the accuracy. Okay, so how accurate that the technique or the approaches that we are choosing in solving that particular problem. Okay, so as I mentioned earlier, there is no specific method, okay, that I can say, oh, you use this method to do this. Okay, because basically when I'm dealing with this an NLP, natural language processing, I will look at the domain of the problem. Okay, that is the most important. Okay, so we focus on the domain and we look at what is, we look deeply the problem of the domain and then the facilities that we have. For example, the knowledge that you have, the features that we have. If we have that domain enough in terms of the knowledge of that particular domain, that you might choose any approaches. It will give you a good result. But you have to compare. Okay, but you have to compare. You are not just choosing that method, because you also need to pick other approaches to compare which one will give the most accurate result. Okay, that is the way basically. Okay, I cannot say that a certain method is the best. It's based on the problem that we are facing, based on the domain that we are working with, and then we always do a comparison. Okay.
Do you think that the approaches that you mentioned before is specific to the language, or only specific to the field?
It could be any language. Okay, it could be any language.
So in general.
Yeah, it's a general. Okay. It's a general to any language, because every language has a grammar. Okay, every language has grammar. Every language has their own Of course, when we are working with this processing, if you concentrate on English, that you will concentrate on English. That means your knowledge base cannot be mixed with different language. Okay, but if you do have a different language or knowledge base, but you have to convert it from one language to another language, the language that you want to concentrate with, if you are working with Indonesian language, for example, but your resources is everything in English. Okay, but first of all, you have to translate all the English resources into Indonesian language to make that your processing for for one language, which is Indonesian. Okay, because we during the processing, we don't want to deal with a different language. Because we are dealing with a we are dealing with a method with the calculation, so we don't want that other language appeared in the between of the processing. So that will be a bit messy when you do a processing. Your knowledge base is a different. Okay, knowledge base will be in one language. If you have different language previously, that means you have to translate it first.
Okay, thank you very much. So I'd like to read the questions in the chat box from Putri Ramadhani. She has two questions. First, on the implementation of semantic text analysis approach, WSG, using machine learning, what is the best technique? The best technique, you have mentioned it. SVV, unsupervised, supervised, unsupervised, or semi-supervised, or maybe it depends on the word. And the second question, how to treat abbreviation and acronyms in WSG approach? Thank you very much. Okay, those two questions.
Okay, for the first question, it's about the semantic text analysis approaches. What is the best technique? As I mentioned earlier, there is no best technique. Okay, it depends on the problem or in the domain that you are facing with and you are dealing with. And for the second question, how to treat the abbreviation and acronym. Okay, so when we go to the basic natural language processing, okay, so basically to recognize one word having the same or the exact spelling. So before that, actually, we look a word, one word. We look at every single character. Okay, so we know that the alphabet will be A, B, C, D. For example, if it's a book, there is a combination of character B, O, O, K. So before we can recognize B, O, O, K is a book, basically we are going through the process to recognize the alphabet. If we are dealing with the that will be another small tree to showing that the spelling of book. After B, followed by O, followed by O, followed by K. Okay, that is a sequence of a graph. What we call it is a lexical tree or lexical graph. Okay, because to spell the book, it's a B, must be followed by O, must be followed by O, must be followed by K. So same happen to the abbreviation and acronym. Okay, that means we already identified what is the abbreviation and the acronym. So we already classified it. Okay, collection of this is acronym, collection of this is abbreviation. This is how we differentiate between the abbreviation and acronym. The machine cannot the machine will not or cannot saying that either the word is abbreviation and acronym, but basically we will always come with the features. Okay, features of acronym, features of the abbreviation. If we do have a unique feature to differentiate between the abbreviation and acronym, then we can classify it either the input is abbreviation or the input is acronym. So based on the features that we are giving. Okay, so basically it goes for the basic of natural language processing, looking for the sequence of the characters. Okay.
Okay, thank you very much. And another question from Dr. Maya Susi. Can you share one of your current research?
Oh, I
Maybe,
share.
maybe. Yeah, so maybe regarding the WSD.
Okay, regarding the WSD, actually my current for the natural language processing, I have two projects. I mean currently ongoing. Oh no, I think four. Some working with the social media, looking for the just identifying. Okay, I go one by one. For the WSD, word sentence integration for query, we are using ontology. Okay, so every single concept in the ontology will count the similarity. Okay, we count the similarity, and the similarity is considered the weightage. Either that word is having the same meaning with the target word. Okay, so how to count the similarity? That will be several techniques. We are using n-gram, okay, to see the similarity each concept in the ontology. So I'm the knowledge domain is on Islamic knowledge. So that is the scope. Okay. When we are working with the natural language, we are always born in the domain. Okay, because we cannot too broad, which is we don't have a domain. It can be anything. Otherwise my student will not graduated. Okay, so I have to put some scope for the student to concentrate on that particular domain. So meaning that the word will be around the domain. Okay, so we are not beyond that. So the idea is looking for the similarity, the concept in ontology using an n-gram, and the highest value of the n-gram will consider the most appropriate meaning for that target group. Right, so that is how the ambiguity is detected, and the outcome of that will be tested on the website. Okay, so we will evaluate the frequency, precision, and recall. Okay, based on the SIDS. That is one, and another natural language research. Just now I'm dealing with the ambiguation using ontology. The second one is to enhance the knowledge in ontology. Okay, so we have been researched that ontology people are developing ontologies until we have many ontologies. We have several ontologies, but all the ontologies is basically looking for the same domain. But when it comes to the searching process, if we working with the ontology A, we couldn't find any document that from ontology B because the ontology A and B is separated. Okay, so this project is to merge the ontology. Okay, how we do merge ontology, we are using what we call it, the ontology merging is also looking for the similarity. Okay, so looking for the similarity concept and concept, because when we do merging, it's impossible to, we will get the same word from ontology A and ontology B. Okay, so but those ontology are working with the same domain. So what we need to do, we traverse all the concepts in ontology, and then we do calculate the similarity from one concept to another concept between A and B. Okay, so the most same idea, okay, similarity we also using n-gram. So the highest similarity is considered having almost the same meaning. All right, so from there, from that point, those ontology A and B will be merged together. Okay, so with the merging of the ontology, we expect that the knowledge will be broadened. Okay, and then the searching, they just can cross between A and B because the ontology is already merging. Okay, so if we able to do A and B merging, so we try to make another ontology C doing the same ideas and look at the 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 relevantness of the answer. Also looking for the accuracy by applying precision and recall. And then there is another two projects still in early stage. Okay, so yeah, this project is related with this COVID-19, not specifically to COVID-19, but we generalize it into any infectious disease. Okay, any infectious disease, not necessarily COVID-19. So this research one is looking for the keyword, okay, the keyword of the illness, and then the other two is looking for the prediction of the area. So with this research, we're hoping that we can, through the social media conversation, we traverse the social media. Through that social media conversation, we can predict which area is the most affected for the infectious disease. So, these two projects is dealing with the infectious disease and doing the prediction of areas. Okay, but we are using text-based to identify those problems. Okay, so this project taken by two students. Okay, one is concentrating on the detect the kind of illness, okay, from the keyword, and the other one is looking for the prediction of the area based on the analysis of the social media conversation.
Okay.
The others will be, my other research will be on data analytics, but not, I have two disciplines, as I mentioned earlier. Some of my students doing on data analytics, some of my students doing on text.
Analysis. Okay, thank you very much. I have another question in my phone and WhatsApp. Somebody asked me directly. So, how to evaluate the text analysis? I mean, he mean WSD in supervised, unsupervised, and semi-supervised. How to evaluate the result?
Okay, to evaluate the result, is back to the accuracy of the retrieval, accuracy of the answers given. Okay, so WSC is just a process. Okay, WSC is just a process applying different methods to solve. But when we want to evaluate how effective the method of WSC, we have to apply the WSC into natural language application, such as at the end of the slide will be either you apply your WSC method in information retrieval, in question answering. So from there, you can evaluate the effectiveness of the technique that we are using. So for me, basically I'm using TF-IDF. Okay, just looking for the precision and recall. Really.
So it depends to the algorithm we use to.
Yeah.
Okay.
Whatever algorithm that you applied, at the end of it, when you want to evaluate, you have to apply it into application to see the effectiveness.
Okay. So another question. Okay, here I will read first. There is as you said earlier, there are mix between maybe, for example, mix between two languages. Can we mix them up, or we should treat it separately if there is a mixed language in text? Should we separate them, or we treat it as one collaborate language?
Okay. When we do the processing, we have to work in one language.
In one language.
Yeah. If we doing the processing, okay. But if you work with the application like a machine translation, that means you have to have two languages. You have, for example, you want to translate Indonesian to English, right? That means in your knowledge base you must have two languages. Okay, and then the languages must present in the same particular of domain.
So we process it one by one.
Yes.
Okay. For participant, is there any more questions? Maybe this one last question. Okay, I'll add it first. Do you have another insight to open our mind about the research in WSD or another research relating to text analysis, semantic text analysis? Another insight maybe to open. This is maybe the students that want to have research title. Maybe they start.
Okay, another type of research in NLP. There is many actually. All right. So I still open for any those who are willing to do in NLP. Which is now we are targeting on doing online conversation. Okay, no, usually known as a chatbot. Okay. Previously I was dealing with the question answering is the offline transaction, offline conversation. Okay. But future, I would like to look at the chatbot conversation. Okay, chatbot conversation is a real time. So nowadays in chatbot conversation, people are using a very basic natural language processing. They just go look at template based, keyword based. Okay, but since I myself I have dealing with the semantic relation quite so long, so I have an intention to have this online conversation like a chatbot, but we implement all the semantic, all the disambiguation problem being solved, because we did dealing with this, and then I don't have any problem to supervise or to run a research dealing or putting the disambiguation in an online conversation like a chatbot. Okay, so basically the WSD, if you look at the previous application, I didn't mention of the chatbot because this WSD itself is not really stable. Okay, so if we applied it into chatbot, it could be a problem because chatbot is a online, it's a real time conversation. So if we are dealing with WSD or semantic in chatbot, it could be processing will be delayed if we compare with template and the keyword based conversation. So, but we can look at it how the WSD or the semantic analysis can be applied in the real-time conversation. That will be interesting.
Okay, thank you very much. Okay, if there's no question, maybe we ask Dr. Maya to have closing remarks. But before that, maybe we should, after that we can take a picture together before we close. Dr. Maya, are you still there?
Ya. Ya, itu ada Bu Erna. Dr. Rabia, you still remember Bu Erna?
Yeah. Yeah.
Your
Of course.
friends.
Ya, sekalian datang ke UKM last time.
Ya. Bu Erna masih mute.
Okay. Hello.
Hello.
When I saw your picture, I realized, oh, this is Dr. Rabia.
Yeah.
Your room is
UKM.
your room is next to my room, yeah. So we can make maybe join research next time, boleh tak?
Boleh insyaAllah. Memang boleh. Dialu-alukan.
Itu dia.
Ya. Tapi macam masa kita PhD dulu macam ingat tak ingat ni. Ini the next room, when you mention the next room, macam yelah, but sometimes I datang, you tak ada. You datang, I tak ada. So that's why dia punya, so ingat-ingat lupa. When Maya told me about Ibu Erna, nama tu seems familiar, cuma lupa where macam mana.
Ya, saya pun dah tengok picture dokter. Ya, saya kenal ini. Saya cakap dengan Dr. Maya. Saya ingat. Last time kami pergi UPM, jumpa dengan Kak Lili, dengan Patty juga.
Ya, tapi masa tu tak sempat jumpa lah. Rasanya dengan saya ada, I think Maya ada kontak. Tapi tak sempat.
Dr. Erna tak ikut.
Okay lah, next time lah ya.
Yang Ibu Erna tak ikut tu jumpa Maya.
Ya. Maya pun cakap, Bu Maya cakap yang pergi UKM. Dia cakap juga kan, Dr. Maya mention juga lah, Dr. Rabia. Dr. Rabia kenal dengan Bu Erna. Yang mana ya? Yang mana satu? Tapi dah tengok Your picture saya ingat lagi lah.
Ya, nama tu familiar.
Yeah.
Nama Ibu Erna tu familiar. Pernah dengar.
Oke lah. Next time boleh buat collaboration maybe ya?
Ya. Sure.
Oke. Pak Dhani mungkin boleh ikut.
Silakan. Terima kasih. Yes.
Oke.
Like
Thank you Dr. Rabia for sharing with us here. Oke. Next time boleh terus datang Medan lah.
InsyaAllah. Sekarang ni tak boleh COVID-19.
Lepas COVID lah. Thank you Dr. Rabia.
Dr. Maya, please, time is yours to closing remarks.
Kita pakai bahasa Indonesia aja ya, lebih familiar. Terima kasih banyak Dr. Rabia atas sharingnya. Mungkin ada mahasiswa di sini yang bukan hanya mahasiswa pasca, bukan hanya master PhD, ada juga yang bachelor yang ikut di sini. Maybe next time akan ikut mengambil masters di sana. Apakah masih ada slot untuk mereka kira-kira di salah satu project dari Dr. Rabia mungkin?
Ada. Those who are willing to do data analytics also welcome instead of just an NLP.
Okay. I'll contact you later. Oke, terima kasih banyak untuk semua yang hadir. Mungkin Pak Dhani kita apa dulu ya?
Take a picture ya, foto-foto ya.
Foto dulu, tolong di on-kan kamera.
Of the participants, please turn on your video, your camera. Okay, the admin, operator, please.
Ada sintong ya.
Do your magic. Okay, maybe I will count to 3. Yeah. There are 4. We will take 4 times because there are 4 what is we call for page, yeah, 4 pages. So we start from the first page, 1, 2, and 3. Okay, the second page, 1, 2, 3. The third page, 1, 2, 3. Okay, for the last page, 1, 2, 3. Okay, thank you very much.
Okay, boleh ditutup.
Thank you very much for Dr. Maya for the closing remarks and for Associate Professor Dr. Rabia Abdul Qadir for the sharing session, for the very fruitful discussion. We have a new knowledge about what sense disambiguations. That's one of the problem in semantic text analysis, and we hope that in the future we can have research collaboration, USU and UKM, hopefully. And for the participant, maybe we have new ideas what to do in our next research. Okay, thank you very much for attending this lecture, and I hope we can meet in the next another lecture. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih Dr. Rabia.
Terima kasih semua sebab menjemput saya juga.
Our next webinar on 3 o'clock is Prof. Rahmita from UPM.
I tengok the schedule.
Okay, thank you.
Okay, thank you.